Good evening, guys. We'll talk a little bit today about understanding how to do expected values in decision trees. So, the central piece of the puzzle is understanding a basic decision tree, how to create it, and how to create an expected value calculation out of a decision tree. So, as we move forward, we'll start off with possibly an example. So, here it goes. Suppose there's a company that the company says that, I'm planning to decide on whether I should buy or whether I should build, right? Which is, should I outsource it from someone or should I build it internally? And based on that, so you say that, all right, I want to buy it, I want to build it. So we start off by saying, which decision should you take based on a series of parameters, right? And the first question that you ask yourself is, all right, so as you begin there, you say, all right, should we buy or should we build? Right. Now you know that, so suppose based on your own industry, and you say that, well, if I get to buy something, I think my chances of making a profit is going to be possibly 30% or 0.3. If I build it, my chances of making a profit is going to be 80%, which is 0.8. However, to build it, you're going to need both labor costs and material costs, right? So you've got labor costs and material costs. And you realize that, all right, material costs themselves are going to cost me, suppose, $80,000. And labor costs are going to be about $20,000. Right? So suppose if you want to buy it, you have two other costs. The cost of contracting, and then you have the costs of possibly monitoring the contract. So, monitoring the contract, the likelihood that you'll be able to monitor the contract perfectly is only about 50%, right? Because they're so far away, you really don't know. And the cost that you'll be able to come up with the best contract in the world is likely to be maybe 80%. Suppose you've got a very good lawyer. Now, in case things fail, the cost that you'll have to bear if the contract goes off would be perhaps 40,000. And if you don't monitor things, you might have quality issues, which might have a cost of 50,000. So now, on the build side, the ability, for example, the probability that you're going to get labor right on time might be just 40%, and then you're going to get material on time might just be 50%. However, and then your material costs are 80,000, your labor costs are 20,000. So all you do is you start from right, you start calculating right to left rather than going. So you build the decision tree left to right and you calculate right to left. So in this case, we're first looking at the build scenario. So this section would be 20,000 cost times 0.4, the probability of getting it. Or you could have put it in as well the 60% of actually not getting it. So, but depends on how you want to frame the issue. And 80,000 times 0.5. So that's equal to 2 fours are 8,000, 8k, plus 8 fives are 40. Right? So that's 40k. So this is 48k. So the probability that you're going to, or the amount that you're going to likely to be losing if you go for a build, it might be 48k, and the amount your cost on the buy side is then going to be 40k, this one, times 0.8, which is 32k, plus that was 50k times 0.5, which is 25k. Now it's telling you that 32k and 25k together would be 57k. So if you're going to go for a build, for a buy, your likely costs might be 57,000. If you're going for a build, your likely costs are going to be 48,000. Now, you could say that, all right, based on historic commitment, or based on this company, how they've either chosen whether they want to outsource it or insource it, what do you think their entire cost consideration ought to be? All you say is therefore 57 for buy times the probability of going for a buy deal is 57 times 0.3, which is 5 threes are 15 and 7 threes are 21, which is 17.1k, and the cost of, or the factoring in of, the expected factoring in of a build scenario is going to be 48k times 0.8, which is 48 times 8 would be 32 and 64, so 38.4k. So all you're saying is your entire scenario, regardless of how the company ends up moving, whether they want to create a buy project or a build project, you should factor in a total cost consideration of 17,000 and 17.1 and 38, which is 48, 55, 55.5k. So it's a very, very straightforward example, without going into much more detail, and this should give you a quick idea of what the basic gist of decision tree is, and we'll continue on